Ladder Recognition Team. Our team member are Ben Yifang, Yue Gao, Ziqin Shi. Our pursuit in this final project is to recognize the handwritten digital and use the deep learning mode. In this project, we trained by the MNST dataset and applied some basic mode of deep learning neural network, and the result is pretty good as the 98.3% like the accuracy, and then the architecture of our deep learning mode is the convolutional neural network structure with Linux 5 mode, and after that we also do some improvement to our mode as we apply the probing algorithms to speed up the training process because the previous process is pretty slow. Here is the way we import data here, and we use the CV2 as the OpenCV library built in Python to read image data and to process them as a matrix to do the following training. And then we split our dataset into validation dataset and test dataset, and we define the weights, bias, and convolutional network and some other things here, and also define the batch function to do the to split the training data into different small batch in that. And here is the parameter in different layer. First layer is a conventional neural network. Second, 2, 3, yes. And we only have a 3 layer of the convolutional network. And then we use TensorFlow framework to build them into one mode here. And we have a dense layer in the last, and get a result here like y predict. And our cross entropy use the reduce mean, and the optimizers use the cross entropy here, and the prediction use the algorithmics function, and the correct predict use the equal, just the minus, and accuracy use the reduce mean here. And then we can see our function likely here to do the iteration. We have about 29 epoch and get about 0.925 accuracy here is pretty good. And after this mode, did we did some visualization for our data here. The cost the cost with the iteration increase. Then after that, we did some improvement use the proline in the TensorFlow framework. Here we changed out some hyperparameter to fit our mode here to like the proline frequency to 1, and the target spread in 2.9, and the end proline step as 215, which not too round. And final, like here, we in the same time we did 49 epoch here with the 0.8875% of accuracy, and it's pretty good. And we can see the curve here. So maybe some feedback of our improvement here is that we make some noise to disturb the cost change here is not uh, not only increasing curve here. So this is the setback of algorithm. So the conclusion here is that we can do pretty good job in the handwritten English letter with the convolutional network, neural network, and LearnNet 5 modes. And also we can do some improvement on the time consuming here by throwing some uh, meaningless there, something here, and but it will lead to some disturbing the cost decreasing part.